Yeah, so there's the projector hanging. Okay, and there's a rope and a rope. Then not for the projector, but then you know that the upward force and the downward force is the same. So this FG is going to be the same if this is force number 1 and this is force number 2, then forces up must be equal to forces down, forces left must be equal to forces right. So if you have this horizontal component, so 2 horizontal must be equal to 1 horizontal because the object is not moving. So that means anything that pulls it to the left must be equal to anything that pulls it to the right. Also, you know that anything that pulls it up, so all the F ups together must be equal to all the F downs together. So please remember that when an object is in equilibrium, there is no net force. So you can't calculate the resultant force because there is none. The object standing still or moving at a constant velocity. Okay, so that's the first thing you need to remember. Then if it's not in equilibrium and you need to get the resultant force, then, so say you've got an object there and there's a force pulling it this way of 20 newtons and there's a force pulling it this way of, let's just say 30 newtons. And we give you some angles. So we say that this angle here is 10 degrees and this angle here is 15 degrees. And I ask you for the resultant force. Okay. Now remember, so the two methods, if you're drawing it from the same point, then you need to remember if a force pulls that way and a force pulls that way, it can't go that way. Okay, some of you do that. Very wrong. So what you need to do is say, okay, it's as if they were happening one after the other. So you need to, from here, you need to complete the parallelogram. And your resultant force will be here from where they start to here where they would end. That would be my resultant. Happy with that? Okay. Why not?
Parallelogram.
That's the parallelogram method. You never are forced to use that because it's not in the ZAGs anymore. So the one that we did the most and that we like the most is if you rather draw them head to tail. So head to tail means you're going to draw the first one and you're going to say, there it goes. That's my 20 newtons. Where this one ends, you're going to do a new line and you're going to say, oh, and you need to show the angles, 10 degrees. Every vector must have a size and a direction. Then from that point, you're going to draw the next vector, and that angle there is 15 newtons. And then your resultant is, and the angle, 15 newtons, angle 30. Oh my goodness. See, my brain is dead. The matrix have been killing me. Okay, so there it's 15 degrees, and this one is 30 newtons. Now your resultant is always from the start of your first one to the end of your last one. So head to tail is always the easiest method. So you're going to do from the start of the first one to the end of the last one. That's my resultant. Can I get this using trig?
No, this is the right angle.
Why can't you can't use trig? You guys haven't done the sine rule or the cos rule yet. If you know how to use it, you can use it, but I'm not doing it now. So you'll know later in maths. I'm not going to do it with you now. Okay, so what you do need to know in science is how to use components to get it. So what you're going to do is you're going to take each of these vectors and you're going to get its vertical and horizontal components. So you're going to say, for this one, I have a horizontal component pulling it this way and a vertical component pulling it that way. So here, this would be 20 sine 10 because it's opposite. Maths is fine, right? For this one, it's going to be 20 cos 10 because it's adjacent. Still with me? Then you're going to do the same for the other one. You can do it here or there, it doesn't matter. I'm going to do it here because I don't want my triangles to be on top of each other. So here I've got a downward force here, and you do the perpendicular components. So here, if that angle is 15, it means that this angle is also going to be 15, because they're alternate angles. Or you can say this one is 90 minus 15. It doesn't matter what maths you use. Yes?
So the 15, ma'am, how do you know that those angles are parallel?
It's a horizontal line and a horizontal line. I'm drawing the question even said perpendicular components. I said so they must be perpendicular to each other. So that means this is opposite. So this is going to be 30 sine 30. Why do I keep on doing that? The angle is 15. 30 sine, and this one is adjacent, so it's going to be 30 cos 50. Now, how am I going to get the resultant?
You work out the horizontal and vertical.
Good. So if I look at all the horizontal components, I've got this one going to the right, and this one going to the right. If they're going in the same direction, what am I going to do? I'm going to add them together. So 20 cos 10 plus 30 cos 15. And I'm going to do the same with the vertical. The vertical, though, this one is up, this one is down. So what must I do?
Minus.
I have to minus. So I'm going to say, well, you could have worked them out to see which one is winning first if you really wanted to. But it doesn't matter. You can say 20 sine 10 minus 30 sine 50. And then you get an answer for each of those. Tell me what you get for horizontal.
48,67.
And for vertical?
4,29. Listen.
All of you check, did you get this? Okay, so I made my up one. This was up and this was down. So that means this is going to end up being up. Was it negative?
It's negative. If you're doing it that way, it's negative. But then if you're doing it like with the 30 sine first.
Okay, no, that's fine. I wanted to do it like this so that you can see it's okay. Your answer will sort itself out. So if you did it my way and you didn't, you're going to end up with minus 4,29. But then because this was up and this was down, we know that this is going to be 4,29 down. And this one is to the right. Now to get the resultant, I have to put the one to the right, which is the 48,67, the one that's down, which is 4,29, and where's my resultant going to be?
From the starting point to the end.
Good. From the start of the first one to the end of the last one. That's my resultant. How do I calculate the size of that? So if the question says magnitude, then you're just going to say R equals square root of 48,67 squared plus 4,29 squared. And it's again your calculator's job. What does your calculator say? Make sure you can do this on your calculator, guys. Are you still here, Justin? Do you want a calculator to play with?
It's 49,06.
What did you get, Penny?
I got 48,85.
I got 48.
Oh, no, I did one. I said 48,867.
Yes.
48,886.
What's the unit?
Newtons. And now we work out the bearing.
Now, if the question didn't say magnitude, you still need to go and work out the bearing. How do we work out the bearing? It's always going to be tan. So you're going to say, okay, to get that angle, it's going to be tan theta is equal to opposite, which is the 4,29, over adjacent, which is the 48,67, and you do shift tan and you solve. And you get your angle. What do you get?
Um, 5.04.
Did anyone else also get that?
Yeah, is that like a people theory?
So now we know this angle here is that. But now you need to decide. If the question gave you northeast, southwest, and you get that angle, then you're going to say, therefore, my resultant is 48,86, 5 degrees south of east. So you're going to say 5,04 degrees south of east.
Could we also say plus 90?
That if the question gave you bearing, remember, if the question give you northeast, southwest, you give northeast, southwest back. If the question gives you bearing, you give bearing back. So you could have also said in this, if they didn't do anything, then you're going to say, okay, R could also be 48,86 newtons on a bearing of. And then it's the 90 that you already have plus the 5,04. So that's going to be 95,04 degrees. So you can do either one of these methods, but if the question gives you northeast, southwest, which one would you use? The top. If the question gives you bearing, you're going to use the bottom.